Let's start with my introduction. My name is Lok Sundar. I'm a dedicated data scientist with a solid background in data analysis, data science, statistical modeling, and machine learning. I'm currently pursuing my master's degree in business analytics at University of Texas at Dallas with a major in data science with an overall CGPA of 4 out of 4. I also hold an executive master's degree in machine learning and AI from Liverpool John Moores University and a bachelor's degree in computer science and engineering. Throughout my academic and professional journey, I have gained hands-on experience in data manipulation, data cleaning, data mining, and visualization using programming languages such as Python, PySpark, and R. I worked on several key projects, including creating an employee attrition model, developing a project recommendation system, and innovating an automated data analysis tool called Autobot. You can see them in my portfolio easily. You can access them. They are easily available in online, and they are running in the background. And also published and packaged in Python, which is used for calculating statistical values. I also worked as an analyst at Traders where I worked on project app analytics for major retailer Walmart. These experiences has honed my skills in deriving actionable insights from complex data sets and identifying patterns and driving business decisions. I'm excited to participate in this program because it aligns with my experience and interest in data science and machine learning. I believe this program will provide me with an opportunity to further enhance my skill, apply my knowledge in practical scenarios, and make significant contributions to the field. For this challenge, I have chosen to work on the IMDB dataset. This dataset is interesting because it provides a real-world application of natural language processing, which is widely used in various industries. For instance, NLP is used in customer service for sentimental analysis, and in e-commerce for product recommendation based on user reviews, and in social media platform for content moderation and trend analysis. Working with IBM datasets allow me to explore these applications and gain practical experience in handling and analyzing data. First thing first, let's start with the project. After reading the data from the Kaggle directly, we use various data cleaning techniques using regular expressions. And after regular expressions, we will use a cool trick called lemmatization, which helps us to simplify the words to their basic form called lemma, which makes them easier to understand. Next, we will take a quick peek at our data. We will see that there are equal number of positive and negative reviews in the data. We also look at how long the reviews are and create word clouds to see which words pop up the most. If you see, this is the overall word cloud, which is having movie, one, watching, or most frequent words. Now let's dig deeper into the sentiment of our reviews. We'll split them into positive and negative clouds and work on them separately. So if you see the word clouds are the positive word, in the positive group, we will find the words like great and love, while in the negative group, we will see words like bad and worst. To understand your reviews better, we will use something called as 10 grams of the data. We see that these are the top 1 grams in the data, positive and negative separately, and this is bigrams and this is trigrams. Based on that, you can see that there are some words like don't waste time. These three words combining can give a good sense for the negative word. And for the positive also did great job. These three words combining, you can say that the sentiment is a positive. Now let's dive into the feature extraction. To understand our reviews better, we will use something called as a TF-ID of factorization. It's a fancy way of turning words into numbers. Helps us to see which words are important. We look at both simple and complex ways of doing this to uncover hiding meanings. We see that we read the data and we divided the data into train and test sets, and we have performed basic TF-ID of factorization, and we performed n-gram factorization. This is basic form, and this is the n-gram form where the TDF vectors are created from the single grams and bigrams. Now let's deep into the modeling part. In the modeling part, we have created a normal function to create a confusion matrix, which can be repeatedly usable. In modeling part, we have used various algorithms to test out the data. Some of the algorithms which we used were linear regression, random forest, ridge regression, and XGBoosting. So after going through all the models, we will make all the metrics into a table so that we can see. If you see the table, F1 score is performing best in logistic regression and regression, and AFC score is better in logistic regression and random forest regression. So it's better to go with the logistic regression because it has both F1 score better and AFC score better. And ridge regression is a form of logistic regression. So next step is going for the hyperparameters. So we choose logistic regression as our final model. On this model, we will work on hyperparameter tuning. For hyperparameter tuning, I have used the hyperopt. I went with hyperopt because it smartly adjusts parameter using a method called tree structured path-gen estimator, learning from the past choices. Unlike exhaustively trying every grid value or randomly choice, it moves to the next value based on the previous one, which speeds up in the search for the global minimum. So once I got the best model, I have trained it again on the trained data set and I see the evaluation metrics. We can see that it is giving a good score of 91 in F1 score and accuracy of 91 percentage. Let's see the ROC curve of this data. Based on the ROC curve and precision recall curve, it is evident that our model has performed exceptionally well in sentimental analysis. The precision recall curve, which plots precision against recall, showcase our model ability to retrieve positive instances while keeping false positive to a minimum. With an AUC of 0.97, very close to 1, our model performance is outstanding. This indicates that it can effectively identify positive sentiments while maintaining high precision. The curve further reinforces this, demonstrating the trade-off between true positive rate and false positive rate. Again, with an AUC of 0.97, our model showcases its capability to distinguish between positive and negative sentiments with remarkable accuracy. After this, I have tested this model on the CV, and we can see that even with the 5 splits, it is giving the same accuracy in every CV. So, and it has a very less variance among 5 folds is around 0.00106 percentage variance. So, our model is regularized very well. Generation is a crucial milestone in any model journey as it marks the point where the model becomes deployable. I have tailored pipelines to streamline the entire process, ensuring seamless prediction of inputs. So I have created a function interpret which can do the real-time interpretation. So let's go to any IMDb movie review, a new movie called on voice reviews IMDb. Let's search for it. This is the movie which got recently and we got the reviews. Let's start them by the review rating. Let's take the first review, which is having more text. And let's give it to run our interpretation part where I copy paste the review from the file and it is processing and it is saying positive. Yeah, it's positive because it is having a 10 out of 10 rating. Now let's take a negative rating and it is, let's take a text, copy it and rerun it. Now paste the value, give it to the model. It's saying negative. Yeah, obviously. It is having a 1 out of 10 rating. See, our model worked best on the real-time data also. So the suggested next steps on this model are we can use neural networks where we can extract the each parts of each tag of the words and we can give it as an input along with the word and let's we can see how it's find out. I can do that, but the computation we need some more computation power for that. Another method is we can use a glow pre-trained words where each word is having its sentiment. So we can use these methods to train our words and we can test the model on it. Last but not least, we can also use a robot model which is pre-trained with a huge corpus. We can use that to detect our sentiment. So that's it, guys. Thank you for giving me the opportunity to explain the project.